Hello, this is Mr. Stansbury. I'm going to take you through the 8C assignment. Okay, let's start with number 1A. This says fully factorize. So we have 3x squared plus 5x. What we're trying to do here is find common factors of each of these two terms. So if you'll notice, they both have an x in it, so we can factor the x out. So this whatever's in the denominator here, I know is the part that I'm factoring out. So 3x squared over x gives me 3x, and then 5x over x gives me plus 5, and that is fully factorized. Okay, and if I'm not 100% sure if that's the right factors, if I distribute it back through, x times 3x gives me 3x squared, and then x times 5 gives me 5x. So then I know I have the right factors. All right. D 4x squared minus 8x. What do those both have in common? Well, numbers wise, they both have a factor of 4 in it, and then they both also have an x in it as well. So those 4's reduce down to 1, and then x squared over x gives me an x, and again the part that I'm factoring out is the 4x here, and then those x's reduce down to 1, and then 8 over 4 gives me 2. So that factors out to 4x times x minus 2. All right. G, we've got 4x plus 8x squared. These both, again, have a factor of 4, and they both also have an x. Okay, so I get a 4x that is going to come out of that. And then the x is reduced to 1, the 4 is reduced to 1. Now, this reduces to 1, not 0. That's a common mistake that people make, is that this equals 0, but it doesn't. It's got to equal 1. And we'll show you how here and why it needs to be that here in a second. But 8 divided by 4 is 2, and then x squared over x leaves us with an x there. Okay. Now, remember how we said we can always double check to make sure that we have it right. 4x times 1 is 4x. And then 4x times 2x is 8x squared. That 1, we have to keep that 1 in there, otherwise this 4x will magically disappear, and that we don't want that. All right? All right. The next number 1. Use the rule to fully factorize. Again, this is called the difference of squares. Again, I'm not a big proponent of having you memorize formulas. This is one that you will use so often that you will start to recognize anyway. But basically they're saying if the first term is a perfect square and the second term is a perfect square, it's just going to end up equaling the square root of the first term. So square root of x. So what times what gives you x squared? X. So you say x times x. And then what times itself gives you 4? That's 2 and 2. One will be positive and one will be negative. So that's the factors of x squared minus 4. Okay, E, same idea. This is a perfect square, this is a perfect square. So what times itself gives you 4? 2. So that's 2 and 2. What times itself gives you x squared? X. So there's 2x and 2x. What times itself gives you 1? And that's going to be 1 and 1. One's positive, one's negative. Okay. Again, you don't have to memorize that, but you'll start recognizing that pretty fast if you don't already. Okay. Fully factorize these. So first thing we want to always do with these is see if there's something that they both terms or all the terms have in common. And in this case, they both have factors of 3 in them. Okay, so we can factor that 3 out. Those 3's reduce down to 1, and we get x squared. 27 divided by 3 gives us 9. So we factored that to start with, and now look, this is a difference of perfect squares, so we can keep factoring this out. Oops. So that's going to be a 3, and then these are perfect squares. What times itself gives you x? X and x. What times itself gives you 9? 3 and 3. One's positive, one's negative. And again, if you want to make sure that that works out right, x times x is x squared. So let's just multiply this out. So we get x times x is x squared, x times negative 3 is negative 3x, negative 3 times x is 3x, and then 3 times negative 3 is negative 9, right? And that whole thing times 3, right? So let's see, this negative 3x and positive 3x, those turn into 0. Distribute that 3 through and you get 3x squared, and then 3 times negative 9 is negative 27, and look, that's exactly what we started with. So we know that we factored that out correctly. Okay. D, negative 5x squared plus 1. What do those both have in common? And most people say it doesn't have anything in common. Oops, plus 5. Now it does. Now it's got the 5. A big thing that can be really helpful is whatever your x squared, whichever one of your terms is a possible perfect square, you always want to try to factor that negative out if you can. So instead of just factoring a 5 out of both of these, which they both can, if we factor this negative, a negative 5 out of both of those, now it's going to end up making this work out. We're going to be able to factor this farther. So the negative 5 and negative 5 turn into 1. So we have x squared, and then 5 divided by negative 5 is negative 1. So look, now we have a difference of perfect squares. If you didn't factor the negative out, you would still have a difference of squares. It would just be a little bit more tricky to spot. So I'm going to do negative 5, and then x times x gives me x squared. 1 times 1 gives me 1. 1's positive, 1's negative, and there are my factors. Okay, here's number 1. Use the x squared plus p plus q blah 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 factorization to fully factorize. Again, I'm really not a big advocate of having you memorize formulas. Please don't memorize that. Let's just factor this and make it make sense. Okay, so we've got a is x squared plus 3x plus 2. So what we want to try to do is try to factor this thing out. Now, if the leading coefficient here is 1, which all of these are, I like to try this little thing called the backwards factoring. Okay, so what I do is I start at the far right instead of the far left, how you read. I start on the far right and say, what are the factors of 2 that add up to 3, and see if that works. Okay, so factors of 2 are only 1 times 2, and then do those add up to 3? They happen to, so I know that my factors can be 1 and 2, and you can put 2 and 1 there. It doesn't matter which one goes where. And then I know that x times x is going to give me my x squared. Okay. Now I know that these factors have to add up to 3, so these have to both be positive. Okay, and then you can double check to make sure that you have it right by just multiplying it back out to see if you get what you started with. So x times x is x squared, x times 2 is 2x, 1 times x is positive x, and then 1 times 2 is 2. So that ends up giving us x squared. 2x and x gives us 3x plus 2. So we know for sure that we have the right factors. Okay? Okay, let's take a look at D and try the same idea here. We got x squared plus 3x plus 10. Okay, so I'm going to try to come up with the factors of 10. 1 times 10 or 2 times 5. Those are the only sets of numbers that multiply together to get 10. And then, oops, I put plus in there when it should be minus. That does make a big difference. So that's supposed to be minus 10. So I need to try to come up with the factors of 10 that have a difference of 3. And look, there we go. 2 and 5 have a difference of 3. So this should factor out. We got x times x to get our x squared. And then again, 2 and 5 go in there. It doesn't matter which one goes in the left, which one goes in the right. But I do know that when I add these two numbers together, they have to add up to 3. So that would have to be positive 5 and negative 2 add up to 3. And those end up being our factors. Okay. G, we've got x squared minus 14x plus 49. So I want to come up with the factors of 49 that hopefully add up to 14. So 1 times 49, I don't think so, but 7 times 7 add up to 14. So we can go x times x to get x squared. And I know that my two factors here are 7 and 7, and they have to add up to negative 14, so they have to both be negative, because negative 7 and negative 7 adds up to negative 14, and negative 7 times negative 7 gives us positive 49. All right? Okay. Next one here. Number 2, fully factorize by first removing a common factor. So with a, we've got 2x squared minus, 6x minus 8. So first thing you really always want to do is see if there's a common factor of any of these, and there are. All of these have a common factor of 2. So if we take that 2 out, that leaves us with x squared, and negative 6x over 2 is negative 3x, and then negative 8 over 2 divided by 2 is negative 4. Now with that 2 out, now we can go back and try to factor like we were doing before, which is say, what are the factors of 4, which are 1 and 4, or 2 times 2, that have a difference of 3. So these two have a difference of 3, so we're going to try those out. Okay, x times x gives you x squared. We know that it's going to be 1 and 4. And then we know that they have to add, these two numbers have to add up to negative 3. So we have to do negative 4 and positive 1, and those are our factors. Okay? D, we've got 4x squared plus 4x minus 80. Now what do those all have in common? They all have a factor of 4. So let's factor the 4 out of all those first. And that leaves us with x squared plus 1x minus 20. Okay, now let's see if we can come up with factors of 20. 1 times 20, 2 times 10. I just like to list them all off first, then I don't have to worry about hunting for them. 4 times 5. Are any of those factors of 20, do any of those factors of 20 have a difference of, this is a 1x here, so any of these have a difference of 1? Yep, 4 and 5 have a difference of 1. So we leave the 4 out here. And we've got x times x. We've got our 4 and our 5. And we know that they have to add up to be positive 1. So that's going to have to be positive 5 and negative 4, because 5 minus 4 gives us 1. And negative 4 times 5 gives us negative 20. All right? So those are our factors for D. Okay? For G, let's move that up a little bit, give us a little bit more room. G, we've got 2x squared minus 2x minus 40. Those all have a factor of 2 in them. So take the 2 out front. Make sure you keep the 2 out there, because this is the correct factorization of this, not without the 4. The 4 has to be there. Okay, so same thing here. That 2's got to be out there. Leaves us with x squared minus x, and then negative 40 over 2 is negative 20. Okay, so again, we want to come up with factors of 20. 1 times 20, 2 times 10, 4 times 5, that have a difference of 1, which we already figured out was 4 and 5. So we've got 2 times x and x. Factors of 20 are going to be our 4 and our 5. And now these have to add up to negative 1. So the 5 and the 4, we have to put the signs in from, so we get negative 1. So it's going to be negative 5, and positive 4 will give us negative 1. Okay? Last one for this problem here. 5x squared plus 15x minus 50. These all have factors of 5 in them. So we pull that 5 out, and we're left with x squared plus 3x minus 10. Okay? So we want to look at the factors of 10, which are 1 and 10, and 2 and 5. Do any of those have a difference of 3? Yep, those two do. So we do 5 times, we go x times x to get us our x squared, and we know our factors are going to be 2 and 5, and then we know that these two, the 2 and the 5, have to add up to 3, so it's got to be positive 5 and negative 2, and those are our factors. Okay? All right, let's take a look at the next example. Last set of examples, and we are good to go. All right, so A, we have 3x squared plus 9x. First thing we always want to do is see if there's any common factors, which there are. We can get out of both of those have a 3, and they both have an x, right? So that means we get a 3x out of them. That turns into 1x squared over x. We're just left with an x there. Those x's reduced down to 1. 9 divided by 3 gives us 3. Can't factor that any farther, so we are all done with that one. Okay. Let's try D here. 3x minus 5x squared. Neither of them have a constant that they have a common factor of, but they both do have an x in there, so we can pull the x out, and that leaves us with 3 minus one of those x's reduces with that, and we're left with 3 minus 5x. You can't factor that any farther, so this is also done. Let's try G here. X squared plus 9. So a lot of people will say, hey, look, perfect square and a perfect square. Let's try our little factoring trick here, right? So we'll do x times x. And then remember, this is the factors of 9 that add up to, there's no middle term. There's no term in the middle there. So that's really, you could think of this as x squared plus 0x plus 9. So what are the factors of 9 that add up to 0? There aren't any. So some people will still try to put 3's in there, plus and plus. If you multiply these together, x times x is x squared. That takes care of that. That's good. X times 3 is 3x. 3 times x is 3x. That ends up being plus 6x, which there isn't one in there. 3 times 3 does give us 9, but this part here is missing, so that doesn't work. This is as far as you can factor it. It's factored out as far as possible. Okay. J is x squared minus 16x plus 39. So let's see, factors of 39 are 1 times 39, 3 times 13. Are there any more? I don't think there are. So are any of those factors, do they add up to 16? They do. 3 and 13 do. So we go x and x. We can put 3 and 13 in. Doesn't matter which one goes where. Now we know that these, here's a really fairly the kind of easy way to do this is to think of, okay, what kind of signs do these need to have to add up to 16, negative 16? They have to both be negative, and there's your factors on that. Okay. M, we've got x squared plus 11x plus 30. So we want to see if we can factor those out there. Factors of 30, 1 times 30, 2 times 15, 3 times 10, and then 5 times 6. So there's a lot of them. Factors of 30, which one of those factors add up to 11? That's 31, 17, 13. This one adds up to 11. So we can go x and x, 5 and 6, or 6 and 5, it doesn't matter. And now we know that these two have to add up to 11, so it's got to be plus 5 and plus 6. All right, and then last one, p, we've got 3x squared plus 6x minus 72. If you look in here, look, all of these have a factor of 3, so let's factor a 3 out of all of those first. So we have 3, and now we have x squared plus 2x, and then 72 divided by 3. What is that? Let's see, that's going to be 24. That's what it is. Okay, so now we can try to see if we can factor this here. Are there factors of 24 that have a difference of 2. So 1 times 24 doesn't work. 2 times 12 doesn't work. 3 times 8 doesn't work. 4 times 6, there it is. Those have a difference of 2. So we say our factor 3 times. And then we've got x times x. And then we know that 1's 4 and 1's 6. Now these numbers have to add up to positive 2. So it has to be positive 6 and negative 4. And those are our factors. Okay? All right. That does it for assignment 8C. If you have any other questions, please feel free